We're going to look at intersections and applications of linear equations. Now, whenever you have intersections of lines, the x and y coordinates must be the same because they're intersecting at a certain point on the Cartesian plane. That means if we are to find the x or y value, we just simply need to follow the following. If we equate the equations with the y's equal, then we'll be left with just x's. That means we can solve for x. Thus, to find the x values, we have to equate the equations with y's. And then similarly, if we want the y values, we would equate the equations with x's. So, the model for revenue in dollars, D, from the sale of n items is dr equals 20n. And the cost of manufacture of n items is modeled by dc equals to 500 plus 5n. Part A. Find the coordinates of a point of intersections of these two graphs and sketch the graphs on the same set of axes. So we want the coordinates of where they're equal. Now we can choose to either find d or n first. Normally, by standard, you will find the n's first, or I suppose x's, in terms of how this looks. Anyway, dr equals to dc, so 20n is equal to 500 plus 5n. So then we have 15n equals to 500, and so 500 over 15, which is 100 over 3. Now, you can't really have 33.3 items. So as an intersection of a graph, that's where it is, but you wouldn't normally do that. Now, you might notice I did say we shouldn't change anything from fractions to decimals, but in this case, I wanted to know how many items there were. That's the reason why I converted it. Anyway, we can ignore that now. Once we've got that, we then substitute it back into either dr or dc. Either one is fine. I'm just going to put it in dr because it's just 20 times it, which is nice to work out. So 2000 over 3. Putting that in the graph. Whoops, not x and y. We have n and d. Putting that in the graph. This is dr, and then dc starts at 500 and goes that way. That's a bit too much, I think. There we go. Now you can see there's a gradient. That's nice. That's 500, and then they cross over at 100 over 3 and 2000 over 3. Okay, obtain the least value of n for profit to be made. So that means we want dr to be greater than dc. Now we've already found the point of intersection, which we already knew it has 33 items, but remember 33.3 items is where they break even, so we must have more than that. So we need n equals to 34 items. All right. When we look at linear equations and we look at intersections, we need to look at the number of solutions. Now, this could apply for other things as well, in terms of different equations and graphs, but normally we do this for linear. Now, there's 3 types of scenarios. Case 1, the gradients aren't the same. If the gradients aren't the same, then at some point the equations must cross over because they're not parallel. So that means all you have to do is check if their gradients are the same. Case 2, they're parallel. Parallel lines are defined to never intersect each other. That means their gradients are going to be equal. Case 3 has the parallel lines and the fact that they are all they have the same y-intercept. So what that means is if I pick any point, they're always going to cross over, So then we say this has infinite amounts of solutions. So if you actually look at this has one solution, or otherwise some people say a unique solution, because it's its own solution. Oh my god, what is with this pen? Sorry. Parallel means no solutions. And then the last case, you have infinite solutions. So what you then need to do is just rearrange the equation and check these things. Find the value of m so that the system has no solutions. So if you look on the first equation, we need to rearrange it and find what m is. So let's just rearrange these. So for part 1, I'm going to rearrange it so that we have negative y equals to 2 minus mx. So then we get y equals mx minus 2. And then for equation 2, I'm going to rearrange it. We have 4y equals to 12 minus 3x. So y is equal to negative 3 over 4x plus 3. Now, remember, if we have no solutions, then they're parallel, which means the gradients must be equal to the same. So m must then be equal to negative 3 over 4 for us to have no solutions. Concurrent lines just means that they all intersect at the same point. So all you have to do is check whether or not they intersect at the same point. So 5x plus 3y equals to 1. And we have 4x plus 7y equals to 10. I'll just rearrange all three of these. So then we can actually substitute them in. So the first one, y is equal to 1 over 3 minus 5 over 3x. Yep. Second one, y is equal to 10 over 7 minus 4 over 7x. And the third one, y is equal to 2x plus 4. So just simply make them equal. You have to do it 2 at a time, so let's check the first two. Because one side's all over 3 and the other side's all over 7, I'm just going to multiply them across. So then we have 7 oh my god, 7, 1 minus 5x equals to 3, 10 minus 4x. So we have 7 minus 35x equals to 30 minus 12x. Putting them all on the same side, negative 23 equals to 23x. So then x is equal to 1. And we'll see if these two gives us the same answer. Because if it's the same point, then if we substitute them both into the second equation, they must be the same anyway for the y value. So 10 minus 4 x all over 7 is equal to 2x plus 4. I can multiply both sides by 7, so we get 14x plus 28 on this side, and this side just cancels out the denominator, so we get 18x equals to negative 18. So x is equal to negative 1. I messed up here, that's the reason why it doesn't work. This is negative 1. So because all of them have the next value of negative 1, if we substitute it back into the middle one, they'll have the same value. So they must be concurrent.